So this is question 1. Okay, I think question 1, previous classes, the last 2 classes I had, some of them made the error because they forgot that the water carrying tubes, they are straight tubes. So they are straight tubes from the bottom to the top. So that's why the liquid, the colored water cannot merge. They travel in their own tube. So the red beaker or the red colored water beaker, okay, all the water carrying tubes that is actually submerged in, you see that the red colored water will travel upwards to that part of the flower. So one part of the flower will turn red, the other part of the flower will turn blue. I think this is pretty okay, correct? Because water carrying tubes, they are all straight tubes from the roots all the way upwards. Okay, they have their individual path to travel. Okay, the water has their individual path to travel. It's not like a complex network where they will merge and then become purple. No such thing. Okay, recall this part here. We did the experiment when we were in school, when you were in P5. And you use celery. I use a lot of different flowers for my kids. We use rose, we use carnation, we use even cabbage. Okay, so all of us were able to see, okay, where the tubes are. Can? So if you have time, if you want to play tonight, just quickly go and get one slice of the cabbage, put inside the colored water. You will see how the water moves. Okay, so this question, let me see. Yeah. So if you actually thought that it turned purple, you must have forgotten that they have their own network. Okay, their network is really just straight tubes only, not the complex kind of network. Okay, so answer is D. Any question here? No question, I'll move on. All right. Question 2. Diagram below shows movement of water in the environment. How do you tackle such question? Take note the moment you see water vapor, clouds, and water bodies quickly during PSLE, take your pencil, annotate. Take your pen also can, up to you. Nobody is going to bother about what you write there, right? So water vapor, what state is it in? What state is it in? Quickly. Let me see your answer. Very good. Yeah, I like it when you are responding. Hannah, no, they won't connect at the flower. Yeah, so if you didn't know last time, now you know. Okay, in the flower, the petals, they also have the individual tubes also. Gaseous state, good. So G for gaseous state. G for gaseous state. How about the clouds? How about the clouds? Yeah. Okay, remember, because, okay, I'm going to put L this way, okay, so that you all know that this is L and not capital I. Yes, tiny water droplets. Okay, what about water bodies? Very clearly, it must be liquid state, right? So when you see questions like this, quickly annotate. Why annotate will be good for you? When you do your MCQ, you need to make sure you have time, right, to go through it once more. So you must apportion your time properly. Okay, make sure you don't finish your MCQ paper like only in 1 hour. That is like too long. How much time do you think you should be spending on your MCQ? Tell me quickly into the chat. Okay, how much time? All right, what did your teacher advise you? Did your teacher advise you on the timing? Yes or no? Denise, did your teacher advise you? Around there, right? Yeah. So I always advise students, take 1 minute or less for one question. There are 28 MCQ. Some questions, 30 seconds, you can complete, right? Because it's a very straightforward one. Then some you actually need slightly more time. You will be surprised. Some questions maybe more than 1 minute. So you have to make sure, quickly annotate, write down certain points so that when you come back to the question, you don't have to read the whole thing again. So how long do you take? No more than 30 minutes. I always tell my own students, no more than 30. The best is you can finish it in 20 minutes. The best. If you are taking too much time reading a question, right, jump to the next one, but make sure you come back. Circle the question number very big to tell yourself you have not done that one. Okay, you are skipping that one. These are the strategies you must remember. So when you go back to the question, you see the big circle over the question number, you know you must do that again. Or those that you are unsure, make sure you circle big the question number, right? Like this. If you look at the screen now, circle like this, very big. That means you must go and check again. You're not very sure, or you don't know. Okay, or you jump, you skip. Make sure you indicate so that you don't spend too much time just staring at one question. Some of us are, okay, I used to have this problem, okay, because I am like, I have OCD, obsessive compulsive disorder. So I must do things step by step, must finish one, then I can go on to the next one. How many of you are like me, have this issue? Okay, if you don't finish one question, you will not go on to the next one. Try to get rid of this habit. Yeah, I always will have this kind of issue when I was younger. Then it's like, I don't finish this one, I cannot go on to the next one. I don't feel comfortable. I feel so uneasy. Cannot. And then I lose the time. Right? Only when I experience it, losing the time, I feel the pain, then I change. So all of you, please don't go through that like me. Okay? Do your PSLE once and do it well. All right? And move on in life. Can? Promise me. So the next time you do this, don't know how to do, circle, annotate everywhere. The paper is yours. Okay, the paper is yours. You just have to do the necessary. So now from from liquid to gas first. Liquid to gas is only A, right? Okay, so we have A, yeah. Then C is liquid to liquid. So this is wrong, this is wrong. Now from gas to liquid, you only have B. So that's why our answer is C. Okay, so the moment you annotate, you can check quickly after that. Priya, can I get the tips here, okay? Next one, question 3. A syringe contains air and some water. Okay, so there is air here. Okay, if I were to draw the particles of water, yeah, they are close. They are not arranged in orderly arrangement. Okay, but air particles are like very far apart, something like that. Okay, so there's a lot of space between the particles. Have you all learned this before in school? Okay, about the arrangement of particles? I hope so. Yeah. Okay. Yeah. Okay. Yes. Good. So if you check, this is just an example. I took this diagram from the internet. So gas particles are arranged this way. When I give it lesser space, that means if I push the plunger downwards, okay, I give it a push, the plunger is pushed downwards, I cause them to come closer together. Another way of looking at it is, think of your own classroom. There are how many students in your class? Is it 30? Is it 40? 40, right? So little some of you. 37. Okay. Maybe Hannah says 31. Okay, and then Tommy says 37. Okay, Hakim also 31. Around 30, right? Somewhere there. It can even go up to 40, I know. So your classroom has 40 students. So do you all spread out and occupy the space, or you all squeeze at one corner? Priya, you all don't squeeze, right? You all spread out, right? If I put you in a bigger classroom, will you spread out? Spread out more, right? But if let's say I put your whole class in a classroom that is half the size, do y'all have to spread out as much as you can? Y'all won't be stuck to each other like shoulder to shoulder, right? You're not going to do that, right? So you are behaving like gas particles. You will spread out. You will occupy all the space given to you. That is the thing. Yes, Brian. You all behave like gases. That's true. So if I were to force you to go into an even smaller room, you will still want to maximize the space, right? You're not going to huddle and hug each other like the penguins do. No. So that is how gas will behave. If I put you in the hall, many of you will run around, right? Or you're going to sit there and then hide in one corner. Usually people will not. Usually kids will not. So yes, that is how gas behave. So imagine this is like the students. Okay, you will just want to occupy all the space available. That is why gases do not have a fixed volume. Clear? No fixed volume. Any space you give it to the gas particles, they will try to occupy the whole space. That's how it is. So in this case, the plunger can move, right? Because there are a lot of spaces. If you take a look over here, these are actually the space that they can walk into, not walk into, they can move into, they can come closer together. So there's a lot of space between air particles. Answer is A. Plunger move downwards because no definite volume. And I explained why no definite volume already, right? Because they will want to occupy all the space given to them. Joseph placed object T on a weighing scale. I like this question. The scale showed a reading of 8 units. So at first 8. Then he placed a bar magnet at the top. There's a 1 cm gap. And then what happened is the scale now show an increase in reading to 10. 10 units now. So what can you say? What can you say about what happened over here? Let's see the word. Let me see whether you can type in that word. That word is important. Okay. All right. Repulsion is a very important word here. There is repulsion. So there is like a push downwards. So what can you say about magnet T? It is a very good. Okay. Magnet. You got it. What is the pole here? What is the pole here of the magnet? Yes, Kiara. Oh, cannot see, huh? So this is north and this is south, right? So right now, we are supposed to look at this next part. He flipped the bar magnet over and held it 1 cm above object T. So imagine I have my object T, and then this is the north pole. Okay, so what will happen? Now you're going to see a traction. Because it is 1 cm above the object T, when there's a traction here, you are going to see that this object T is lifted off. Okay, my drawing not so nice, but that's fine. Lifted off the weighing scale. So it's lifted off the weighing scale. It's not touching the scale anymore. So the reading will be 0. Any question here? No question. Good. Yes. T will be attracted to the magnet, move away from the weighing scale. Thus, there is no load on the weighing scale. Reading is 0. Yes. Why do you like A? Why do you ask that question, Tommy? Why do you ask that question? Why do you like A? Do I like A? I like W. I like D also. Oh, there are 4 answers. There are A. I see. Okay, I like W because my name is Wendy. I like letter D because short form of my name is D-E-E, D. Yeah. So it's something you all know about me today, yeah? Okay, question 5. Now, Tommy, to answer your question about the answers, 4 of them are A. I didn't set all this. Okay, all these are actually in the system in the portal. Okay, yeah. Now I answered your question, right? So I'm not the one who said all this. Yes, Alex, it's uploaded. And your answers are actually found in the Google Sheet also. It's there. Okay. You're welcome. Okay, now 2 circuits using identical bulbs and batteries in working condition were set up as shown. Which circuits will the bulb light up? Okay, so take note, this one definitely will light up, right? But circuit B, can you see this part here? The connection, negative pole, negative terminal connected to the negative terminal. So the electric current is will be cancelled out, isn't it? We actually explored this before. Similar question. So B will not light up. Answer is only A. Yeah, A is the answer. Yeah. So there were students who commented, Miss Tay, how come I see that this part here is broken? So I thought that it's not going to light up because the bulb is broken. Now, is the problem with the diagram? Okay, it's actually a problem in the diagram, but it was stated very clearly. All the bulbs and the batteries are in working condition. Can you all see that? So in case some of you are thinking, the diagram not so clear, in PSLE, it shouldn't happen. But in case it does, read very carefully, all right, some of the important information in the question and highlight. I know y'all are not allowed to use highlighter. How many of you were told not to use highlighter?